Hello everyone, a very good morning to all. Today we are going to solve a problem from last year's question paper which was asked for 13 marks. Let's see the problem. A horizontal pentagonal prism, base edge 25 mm, length of axis 60 mm is resting on one of its rectangular faces centrally on the top surface of a cube. Side is 50 mm. The axis of the cube is perpendicular to HP and the axis of the prism is perpendicular to VP. Draw the isometric projection of the combination of solids. Show the common axis and indicate the direction of viewing. Give all the dimensions. Here two solids of the combination are cube and a pentagonal prism. Now the cube is resting on its surface, on one of its base or surface or square base on the HP, and the axis of the cube is perpendicular to HP. See, in the cube all three center to center lines are axis, all are same, so an axis is perpendicular to HP. And second solid, pentagonal prism is horizontal. Horizontal means the axis for the prism is parallel to HP. Base 25, length 60, resting on one of its rectangular faces. So the rectangular face of pentagonal prism is resting centrally on the top surface of cube. Now centrally means center of this rectangular face, this center will coincide with the center of the upper surface or upper square of the cube, like this. Now axis for the cube is perpendicular to HP and axis for prism is perpendicular to VP. So the axis is perpendicular to VP. So this is the final position. Now here first we have to project the cube and then we locate the center of its upper surface, and then from that point we will start projection work of this prism. So we will start from projection of cube. So for cube, side is 50 mm. So marking limits of ISO 50 for side 50, marking limits of ISO 50 along first and second ISO axis, ISO 50 along first ISO axis and ISO 50 along second ISO axis. Then drawing lines parallel to first and second ISO axis from these 2 points, parallel to first ISO axis and then parallel to second ISO axis. We get the base of the cube. So this is the base. Next, from all 4 corners, drawing lines parallel to third ISO axis. Aim for the length equals to the side. The side is 50. So we have to take ISO 50 from all 4 points. Right. So ISO 50, ISO 50, ISO 50 and ISO 50. Now from all 4 points, again drawing lines parallel to first and second ISO axis. Or simply joining these corners. So this is the cube, first solid of the combination. Now drawing all center lines for the cube, passing through all 4 midpoints of upper base and lower base. So center lines are lines parallel to first and second isoaxis. From first and second base. For upper base, parallel to second isoaxis and parallel to third isoaxis. Fine. Now from these 2 points, drawing solid axis of the cube, now pentagonal prism is resting on one of its rectangular faces centrally on the top surface of cube. So this is the top surface of the cube, and the prism, pentagonal prism, is resting on its rectangular face, one of its rectangular face on the top surface of cube. So the center of this rectangle of size of the rectangular face is 60 by 25. 25 the side and 60. So this rectangle of size 60 by 25 is to be placed here centrally. So from the center we have to mark half of 25, and here we have to mark half of 60, half of 60. Then we'll get all 4 ends of the rectangle. So along first isoaxis, marking limits of side half of 25, and along second center line, extending this line first, we have to mark limits of 60. So from this point, ISO 30, half of 60, and ISO 30. We have all 4 boundaries or limits of the rectangular face. Now drawing lines from these 4 points. And parallel to first isoaxis. So this is the rectangular face. This is the rectangular face which is resting centrally on the top surface of the cube. And this is the side, first side of the pentagonal base. Now for projecting pentagonal base, we are required to draw a helping figure for the pentagonal base of size 25. So drawing a regular pentagon of size 25. And the size 25 is to be marked from isometric scale. Right. Next, we have to enclose this pentagon inside a rectangular box. So drawing lines parallel to and perpendicular to first base side from all 5 corners of the pentagon. So drawing lines parallel to and perpendicular to this side. This is my first side or reference side. And Y. Okay. Size 25 for pentagon and dimensions of helping box X and Y. Next, locating center of the pentagon by drawing lines from corner to opposite midpoint. Common intersection point. This point is the center. Okay. Y dash. Also drawing center lines from the center. Parallel to and perpendicular to first base side. Right. Now, this is the helping figure along with the pentagonal base, which we have to project here. But the first side is to be projected on this line. So, from this side, from first side, we have to project this pentagonal base along vertical plane of isometric set. So, we have to mark these two limits starting from center. Now, simply we will start from this point. This is the center point of the side. This is the side. This is the side, and this is the point. Now, from this point, this is the length. So, extending this line first, right? And from this point, this is the distance. From this point, this is the distance. Also, first drawing line. Okay, so this is the distance. And same we have to mark on other side. Next, from these 4 points, we have to draw lines perpendicular to horizontal plane or parallel to third axis. And the height is equals to y. So, drawing lines from these points parallel to third or vertical axis, and then we have to mark limits to avoid confusion. The points are A, B, C, D, and E. So these are first 2 points, A and B. Now for C and for the corner, see these corners are S, T, U, and V. So we have S here, this is S, T, and then we have to locate C and U. So from T to C, this is the distance. T to C, this is C. From S to E, the height or distance is same, E and C. Then from C to U, C to U, and from E to V, along the same line, E to V. So these are limits of the helping figure. Right. And last point, D. From V to D, V to D. These are 5 points of the pentagonal base. Again, repeating the process here. So we have A, B, S, and T. Next is from T to C, S to E, S to E. This is E, this is C, and from E to V, E to V, and from C to U, from C to U. and last point from V to D. V to D. So we have all 5 points of front and rear base. Drawing lines, joining these points for front and rear base, and joining all generators right. Next, locating centers of pentagonal rays from S, Y dash, from S, Y dash, Y dash, Y dash, and Y dash. These are limits of center line, and half of X from S. So this is the point, this is the point, and these are two corresponding points. Drawing center lines for front and rear base of the pentagon. This is the point. And parallel to first x-axis. The last from the front center to the rear center, drawing solid axis of the prism. Okay, now we have to show all visible outlines of the solid. So this is the solid resting on its rectangular face, front pentagonal face, or all 5 sides of the front pentagon or pentagonal base. These sides are visible sides. So drawing dark line for them, and then all extreme sides of the rear base. These sides are visible sides, and all generators, all visible generators, and last from this corner to this corner, this is visible generator, and last visible side. So these are visible edges of the pentagonal prism. And for the cube, these are visible edges, showing all visible edges. Okay, here please mark corners of the cube. These are corners, and then please check which lines are to be shown. This is complete projection of the combination. Next, dimensioning. Here we have to show the side of the pentagon and axis. So for axis, extending center lines and drawing the line parallel to solid axis. Side 25 and axis 60. And for cube, For dimensioning, please note all extension lines and dimensioning lines. All these lines are parallel to first, second or third iso axis. Side 50 and also 50, 50. And direction of viewing or observation. Here the axis of the prism is perpendicular to VP. So for this direction, the axis is parallel to VP. So as per the drawing, this will be the direction. So for this direction, axis of prism is perpendicular to VP and axis of Q is perpendicular to HP. And last heading. Now we will check horizontal pentagonal prism, base is 25, axis 60 mm, right, is resting on one of its rectangular faces centrally on the top surface of a cube. Yes, resting on its rectangular faces on top of a surface of a cube, side 50 mm. Axis of cube perpendicular to HP. Yes, axis of the cube is perpendicular to HP. And axis of the prism is perpendicular to VP. This is the axis perpendicular to VP. Draw the isometric projection of combination of solids. Yes. Show the common axis. Here, the common axis means this is the axis of the cube and this axis is the axis of prism. So these are two axes. And if we extend this horizontal axis, these are two axes. Axis of first solid and axis of second solid. And here, common axis means it's nothing like common axis. These two axes are intersecting axes and indicate the direction of viewing, direction of observation or viewing, give our dimensions. Yes, done. Now I request you to please draw this problem on your sheet. And if you have any problem regarding this problem or any other problem in engineering graphics, please write your doubts and comments in the comment section. Thank you.